How we doing, everybody? This is That Our Nerd back at it again with another algebra tutorial. This tutorial today covers different types of numbers. So all numbers that are not imaginary or complex, those are going to fall under the real. Oh, that's real ugly. Real numbers. And we denote this with R. So basically, this is any number that you can find on a number line. So any number that fits in here, any number really that you can think of is going to be a real number. So even if it's -1, right, that would be a real number. 0.5, that would be a real number. The square root of 2 would be a real number. Right? Anything that is not complex would be an example of a real number, and it's anything that has a one-to-one correspondence with this number line here. So then we have something that are called natural numbers. Let's see if we can write this a little better on here. Natural number. And what these are basically your counting numbers. So 1, 2, 3, 4, 5, 6, all the way to infinity. 1, 2, 3, and then the triple dot 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 means all the way to infinity. It does not count 0, and it's only integers, right? So positive integers. So it's not going to be a half, or there's not going to be decimals in it. Just your counting numbers 1 through infinity. Our next set of numbers is called whole numbers. Oh, and this is a capital N. It's like another line you do here if they're looking for notation on them. Whole numbers are all the natural numbers, but we also want to count for 0. So like if nothing were to happen, right? So 0, 1, 2, 3, dot dot dot, all the way up. So that's denoted with the W, a capital W. But whole numbers, well, I guess if your number is a natural number, then it's also going to be a whole number, right? Because they include every natural number, but then we also include 0 in there with it. Our next set of numbers are called integers. Integers. And what these are again, no decimals or fractions or anything, but these also include our negative numbers. So we have -2, -1, 0, 1, 2, and out to infinity. So these are going to be our integers, and they denote this with a capital Z. I'm not sure why, but normally when it's weird things like that, it's because it's Greek or something like that, right? So these are integers. Again, if your number is a whole number or a natural number, it is also going to be an integer, except for these include our negative numbers as well. So we'd want to use these for if we're looking at profits and loss, and you want to denote between when you're making money and losing money, right? So now we have our integers here. Next one is rational numbers. Rational numbers. And what these rational numbers are your fractions. So that's where those are included. So like 5/3, that would be a rational number. Let's see, I don't know, 7/4, that'd be a rational number. What about the number 2? Would this be a rational number? Well, it would be, right? Because we could divide this by 1, and so we can make this a fraction. This also covers decimals that terminate. So if you had like 6.23, that would be a rational number, right? Because we could make this into a fraction. And so what we could do is we could move the decimal over twice and then divide it by 100. So however many times you move your decimal over, that's how many times, or how many zeros you're going to add on the bottom. So 623 divided by 100 is the same thing as 6.23. And so with any decimal that ends, we can make that into a fraction as well. Or if it repeats, so if we had like 4.33, right, with a bar on the top, I'm sure you've seen that before. But if your decimal repeats, you're going to be able to turn that into a fraction as well. So that would be another example of a rational number. And we represent rational numbers with the capital letter Q. Finally, the last one is irrational numbers. Irrational numbers. And what these are basically numbers that cannot be written as a fraction. So these are numbers that after the decimal continue on forever. So the most popular example of this would be pi, right? So pi is approximately, I guess I should do the little swigglies, right? It's approximately equal to 3.14, but it keeps continuing on forever. They haven't found an end for it yet. So this would be an irrational number because there's infinite numbers after the decimal. Another one would be the square root of 2. Right, this is approximately 1.4 or 1-ish, right? But it keeps going on forever as well. So it would be an irrational number. And honestly, most of the irrational numbers that you'll see come in the form of square roots of numbers. So like the square root of 2 is this, square root of 3 is an irrational number. Square root of 4 is not, right? Because the square root of 4 is 2. Square root of 5 is another irrational number. But it just kind of depends. So as a little visual aid, you have real numbers, and in your real numbers you have either rational or irrational. Right, so we have rational or irrational, and within the rational you have integers. Split that up. These are all real numbers. And within rational, you have integers, which I'll just write as int right now because I'm running out of room here. And within integers, you have whole numbers. So I'll just do the capital W. And within whole numbers, you have natural numbers. And so if they had a question and they were like, let's say 5/3. Well, 5/3 is a rational number, right? It's not an integer because it's not on the full counting number. It's not whole, it's not natural, it's rational and real. So this one would be, I forget the notation already, Q and real. But what if we had a number like 2? Well, if it fits in natural numbers, it's a counting number, right? A positive integer. If it's a natural number, it's also going to be a whole number. It's also going to be an integer. It's also going to be a rational number, and it's also going to be a real number. So basically, you figure out what your basic classification of it would be, and then everything bigger would be contained in it as well. It would be another classification. It would also be in that set. So let's say we had a -4. If we had -4, right, whole and natural numbers are positive and 0. Integers include the negative numbers. So -4 would be an integer, but it would also be a rational number, and it would also be a real number. And again, the reason it can be a rational number is because you could take -4 divided by 1, right? So you could turn this into a fraction, and so it would be a irrational number. Anyways, I hope this video helped. If it did, make sure to slap a real number onto that like button down there. Also subscribe if you'd like to see more algebra tutorials. I promise the handwriting will get better on this. Yeah, have a great day. You guys are awesome.